Hi, in this video we're going to build and test a non-inverting op-amp using an LM358 chip. I'll keep the theory light. The full explanation and formulas are in my blog post that I've linked in the video description. This video is about wiring the circuit and seeing how it behaves in the real world. So what we're creating is a non-inverting op-amp, and we can see here how this works. The signal does not flip. Now we are inputting 1 volt on the input as shown by the yellow line, and that is 1 volt division there. And we can see the blue, the output, is measuring at 2 volts, which is exactly the way we want it. Now as the input rises, the output should rise, and when the input falls, the output falls as well. This makes the circuit ideal when you want more voltage but the same signal direction. So the first thing to do to build our circuit is connect the power supply to the op-amp. So the 5 volt rail goes to pin 8 and the pin 4 goes to ground. Next we need an input. I'm going to use a 100k potentiometer and place that there. The outer pin, first outer pin, goes to the 5 volt rail. The final outer pin goes to ground. And the middle pin, the wiper pin, goes to pin 3 on the op-amp, given our input. To create our feedback network, we are using a 10k ohm resistor from pin 1, the output. Then the end of that goes to pin 2 on the inverting input of the op-amp. And then a final 10k ohm resistor goes from there to ground. Next we need to add our test points. So we want to test the output, create a pin 1, want to test the input to make sure we're getting the right value, so that goes to pin 3, and we need a ground. So with our bench power supply turned on and set to 5 volts, I'm going to connect the ground of the multimeter to ground on our circuit. I'm going to connect the live to the input so we can measure that 1 volt set by the potentiometer here, which is correct. Now, if our feedback network here, we should have a gain of 2, so our output should be 2 volts. Which is correct. Now, if I change the multimeter back to the input, let's increase the input voltage to 3 volts by adjusting the potentiometer. Now, what we'd expect to see with a gain of 2 is 6 volts on the output. So if I now change the input to the output on the multimeter, our expected 6 volts is less than 4. This is because we are running the op-amp with a supply of 5 volts. So therefore the op-amp runs out of headroom and clipping occurs. So the gain hasn't changed, it's just the power supply is limiting how far the output can go. And obviously this is less than what we even expected, because if you look at the data sheet, there is some internal resistance and leakage also that goes on. So this circuit is used whenever you need voltage gain without loading the signal source. You'll see it used in sensor circuits, audio stages and general purpose buffers. The full explanation, gain formula and wiring diagrams are all in my blog post linked in the video description. I hope you've enjoyed this video and return again for the next one. Thank you very much.